This is video 209. It's about the action reset and the action puck. Puck will take a random sample from a frequency distribution and not replace that observation. Therefore, the U is for unreplaced. Here is the routine we're going to use. The first thing it does is ask for a value to be put in T that comes from the tick, which ticks every 1/20th of a second. And since it says T goes modded with 150, it goes from 0 to 149, 0 to 149. And it'll take over 7 seconds for it to do that. The next instruction says if T is 0, we're going to do this down here. If it's not 0, we go to EK. Alright, so only when the T is 0, which is like once every 7 seconds, will it come down here and make new observations. Needs a seed number for puck. We make sure that S is going to be a positive number, and then we mod it with 1,000 to make sure it's between 0 and 999. Then we do a reset, because every puck operation has a frequency table, and frequency tables need a work area. And you need to reset in order to erase the old work area and start a new one. Here it fills 15 at list observed with 0. That is because there are going to be 15 possible observations, and we want to know the order in which they're observed. Next, we set up a frequency table. In the beginning we say how many possible observation types are there. It says 5. Next, it sets the total number of observations in the frequency table. That's 15. You do not have to put that number there because the program will calculate the sum of the observations. Next, over a loop for I equals 1 to 5, it puts the number of observations in the frequency table for each of the possible observations. For example, when I is 1, down here it says put the value at I plus 1, so its frequency offset to the value of 1. Then it's going to put the value of 2, 3, 4, and 5, increasing the offset each time. That builds the frequency table. Then it's going to go around a loop from I equals 0 to 14, which means it's going to go around 15 times. That's the total number of observations we have in our frequency table. And since they're without replacement, there are only possibility of 15 things to observe. Therefore, here is our puck, here is our seed, here is our frequency table, here is the value it's going to go find. Alright, in P. Then instead of us here adding 1 to observed, we say no, we want to know what was the first P observed, and we're going to put that in the observed table at offset I. So the first time I is 0, so at offset 0, we put P, the observation, that which was sampled. And we do this till we get to offset 14. We know we stop them because there's nothing more to be observed. Then it adds 1 to S, then it goes home. So the next time the t becomes 0, it sets up a new seed, resets the work area, and does the observations all over again. Well, let's go to the execution of this application. Well, we're going to look at the data. First, we're going to look at the work list called frequency. This is our frequency table. It says there are 5 different types of observations, and here they are, 5 of them. They add up to 15. Well, 1 plus 2 plus 3 plus 4 plus 5 is 15. You can put that number in the frequency table, but the program will add these up and put it in there for you. Well, they take that away, and we go to Data, Work List, Observed. This is the table of values from 0 to 4. And it tells you the order in which they were observed. Since 0 only occurs once in 15, you will find only 1 0. Well, the list ends here, okay? Don't count any of these zeros. But there's 15 values here. The last one is at offset 14. There. You're only going to see 1 0 each time. You'll see 2 1s. There's a 1, there was a 1. Now it's again, there's a 1, and there's a 1. It's always going to be 2 1s. Right? Now, 4 is going to occur 5 times, because that's how many times it's observed if you don't replace them. Alright, so this is sampling without replacement. And we're just looking at the order in which they were found. Alright, that's the end of video 209.